Things changing around us. The changes taking place around us are of two types. They may be physical change or chemical change. We are also aware of changes in which the chemical composition of a substance is not affected. Such substances change only outwardly. There is a change in their physical state. There is no change in them which can be said to be permanent. Such changes which are temporary in nature are called physical changes. There are other types of changes which are permanent in nature. In such changes, the chemical composition of a substance is affected. Totally new substances are formed. Such changes are called chemical changes. Let us now study about a few physical and chemical changes in detail. Physical changes. A physical change is a change in the physical properties of a substance without a change in its chemical composition. As a result of physical change, a substance changes its form, but not its chemical composition. Let us perform some activities to learn more about these changes. Dissolve some sugar in water so that water becomes sweet in taste. Evaporate the sugar solution in a china dish over a burner on a spirit lamp. A white residue is obtained in the china dish. All the properties of the residue are identical to sugar, which was earlier dissolved in water. Thus, we observe that no new substance is formed. Hence, it is a physical change. From this activity, we can conclude that as no new substance is formed, the change is temporary and reversible. The composition of the matter remains unaltered. There may be some changes in the physical properties such as state, color, smell, and many more. The change can be reversed on withdrawing the agent that caused the change. Here is an activity to show switching on or off an electric bulb is a physical change. Switch on the electric bulb in your classroom. What do you observe? The element of the bulb becomes hot and gives heat as well as light. Thus, there is a change, but the element remains composed of the same material. Now, switch off the bulb. What happens? The element regains its original state and stops giving heat and light. Thus, the change is temporary and no new substance is formed. Hence, it is a physical change. Chemical changes. There are many more chemical changes taking place around us. Some common examples are curdling of milk, burning of paper, charring of coal, charring of sugar, burning of wood, and many more. Many biological processes like photosynthesis, respiration, clotting of blood are also the examples of chemical changes. Chemical change is a change in which an entirely new substance is formed with different properties. The change is usually irreversible and permanent. To show that formation of cottage cheese is a chemical change, boil some milk, then add 1 teaspoon of lemon juice, stir well, and switch off the gas. Strain it carefully. Now you can see cheese, and that it is separated. The prepared cheese cannot be changed back to milk. Hence, we can say it is a chemical change. Take a piece of magnesium ribbon and hold one end of it with a pair of tongs. Heat its other end over a burner or spirit lamp. What do you observe? It starts burning with a dazzling white flame and produces dense white fumes. Let the magnesium ribbon burn completely. The white fumes on cooling form a white powder called magnesium oxide. It is a new substance and its properties are different from that of magnesium. The change can be represented as magnesium plus oxygen gives magnesium oxide. Note that you cannot obtain magnesium back from magnesium oxide by any method. Hence, it is a chemical change which is permanent and irreversible. From this activity, we can conclude that a new substance is formed, the composition of the matter has changed, the change cannot be reversed, Heat or light may be given out or absorbed. Rusting of iron. A commonly occurring metal is iron. It is present almost everywhere around us. It may be the railing of our balcony, or the railway tracks, or the body of our car. Rusting is the process by which a brown-colored coating is formed on all iron objects. But this, however, does not always happen. There are a few basic conditions that have to be fulfilled for rusting to take place. As a common observation, it is seen that iron rusts primarily in rainy season. It means moisture, oxygen, and an iron object are the basic necessities for rusting to take place. Take a rusted piece of iron and scrub off the rust from it, and observe the portion of iron below it. It is observed that the portion of iron under the rust is almost eaten away by the rust. It is not possible to alter the process on reversing the conditions. Thus, it is obvious that rusting is an example of a chemical change. Iron plus oxygen plus water gives iron oxide. Methods to prevent rusting. Corrosion of metals can be prevented if the contact between metal and air is cut off. This is done in a number of ways. Coating with oil and grease. Applying a coat of grease or oil on iron articles cuts off its contact with air and moisture, and this prevents rusting. Coating iron articles with paints. Applying a coat of paint on iron articles prevents them from coming in contact with air and moisture, but paint coating should be applied regularly. Galvanization. This is a process of depositing a layer of zinc on iron. The coating of zinc does not allow the iron articles to come in contact with air and moisture. Alloying. Have you ever noticed that some articles like scissors, blades and utensils do not get rusted at all? These articles are made of stainless steel, which is made by mixing metals like chromium, manganese and magnesium with iron. The new substances formed by mixing is called an alloy. Alloying prevents rusting. Chemical changes in fruits and vegetables. When fruits like apple or vegetables like brinjal are cut and left as it is for a while, a brown color is seen on them. This is due to the reaction taking place between the fruit or vegetable and oxygen. This new substance so formed is brown in color. This change is irreversible. This is a chemical change. Physical and chemical changes simultaneously. There are some cases in which physical and chemical changes take place simultaneously. One such example is the burning of candle. When a candle is lighted, the wax in it melts. This is physical change. The burning of the wick is a chemical change. The burning of molten wax is also a chemical change. CXHY plus O2 gives CO2 plus H2O, fuels wax. The burning of LPG gas is also a simultaneous physical and chemical change. It is stored as a liquid, and when it reaches the burner of gas stove, it becomes a gas, and on burning, it undergoes a chemical change to form carbon dioxide and water. Differences between physical and chemical changes. Physical change, chemical change. It is a temporary change. It is a permanent change. No new substance is formed. A new substance is formed. It is a reversible change. It is an irreversible change. Composition of the substance remain unaltered. A change in the composition of substances takes place. Such changes may not be accompanied by the evolution or absorption of heat and light. Such changes are usually accompanied by evolution or absorption of heat. Crystallization. The process of separating a pure substance in the form of crystals from the hot, saturated solution by cooling is called crystallization. This method is used to purify solid substances. At times, Crystals of a substance cannot be seen clearly. It is not possible to make out its shape. Normal table salt can be obtained by evaporation of seawater. Here is an activity to make pure crystals of copper sulfate. To make pure crystals of copper sulfate, take some water in a beaker and add a teaspoonful of copper sulfate in it. Stir the solution till it cannot dissolve more salt in it. Few crystals of copper sulfate may remain at the bottom of the beaker. Heat this and add more copper sulfate, stirring continuously till no more salt dissolves. This is the supersaturated solution of copper sulfate. Now, allow this solution to cool at room temperature by placing the solution where it is not disturbed. Observe the solution after a few hours. You will get the crystals of copper sulfate.